we're trying something a little different.
A little unconventional, yeah.
We are taking the lore of a superhero, specifically DC's The Flash, and using it as a lens to understand a truly massive breakthrough in quantum physics.
It's like about time crystals.
Exactly. And at first it sounds like a weird pairing, right? Comics and quantum mechanics?
It does, but the fiction, it actually helps solve a huge vocabulary problem we have in physics.
Yeah.
We're looking at reports today, one from NYU that just came out, and another benchmark from Dortmund University a couple years back.
And they both describe a state of matter that, well, it breaks the fundamental symmetry of time.
And using something like the Speed Force from the show makes it so much easier to visualize what's happening.
Okay, so let's set the stage with the fiction first. In the Arrowverse series, the Speed Force isn't just about running fast.
Right, it's not just speed.
It's an extra-dimensional energy source. I think they call it eternity itself.
An endless void of time and energy.
But the mechanic that really matters for us today is the vibration. When Barry Allen taps into that dimension, he vibrates at a frequency that's completely distinct from our world.
He's in the room, but he's sort of operating on a different temporal layer.
Perfect. So hold on to that image, a distinct frequency.
And now let's look at the reality. A physicist, Frank Wilczek, he theorized these time crystals back in 2012.
Okay.
So, a normal crystal like a diamond.
Yeah.
Its atoms are in a repeating pattern in space.
Right, a lattice structure.
Exactly. A time crystal, though. Its pattern repeats in time.
Which has to imply motion. And that's where my high school physics class starts screaming, because these things are supposedly in their ground state.
And that is the absolute key. The ground state should be the lowest possible energy, zero motion. Things should just freeze.
But they don't.
They don't. A time crystal keeps ticking. It flips between states forever without using any energy. It breaks that symmetry.
So it's basically perpetual motion. I mean, that defies the second law of thermodynamics.
Yeah.
You can't just have movement without an energy cost.
You can't, unless the system is isolated in this very specific way. Think about what they see in the lab, this thing called subharmonic oscillation. The scientists hit the material with a driver, like a laser pulse.
So the laser sets a beat, like tick, tick, tick.
A very fast, steady beat. But the time crystal, it doesn't follow along. It doesn't sync up.
It just does its own thing.
It does its own thing. It responds at a fraction of that frequency. Maybe it ticks on every other pulse from the laser. It locks into its own stable rhythm and just refuses to budge.
It maintains its own rigidity in time.
Precisely.
And that's the flash connection. That is exactly it. The laser is the outside world, but the crystal is the speedster running inside the Speed Force, vibrating at its own independent frequency.
And it's completely impervious to the chaos of the driver.
Yeah.
It's dancing to its own beat.
And that stability, that independence, it's getting stronger.
Which brings us to that Dortmund University breakthrough in 2024. They made a time crystal that stayed stable for 40 minutes.
40 minutes in a quantum system where things usually collapse in, microseconds?
It's an eternity. It was 10 million times longer than any record before it. But then the NYU study from this month found something even stranger.
Okay.
They saw these particles defying Newton's third law.
Wait, the equal and opposite reaction one, the one law everyone actually remembers.
That's the one. Here, the particles interact non-reciprocally. So particle A can push particle B.
But particle B doesn't push back.
It does not push back. The influence is a one-way street.
That's phasing. That's literally the Flash vibrating his molecules to pass through a wall. He moves through solid matter without the expected physical reaction. The wall just ignores him.
It is interaction without consequence.
So this is mind-blowing, but why does it matter for, people listening? We're not building superheroes here.
Not yet, anyway. No, we're building computers. Quantum computers. Because these crystals are so incredibly stable, because they resist getting knocked out of their rhythm, they are the holy grail for quantum memory.
They can hold information without it degrading. It solves the fragility problem.
Exactly.
Okay, so I'll leave you with a final thought to chew on. We have now created a state of matter that exists in a closed loop. It moves forever without any energy, and it ignores the basic laws of interaction.
It's a little pocket of reality that's playing by its own rules.
So if a time crystal creates a moment that's locked in a repeating loop, totally unaffected by the rest of the universe, have we effectively just built a microscopic Speed Force prison?
That is a terrifyingly accurate way to put it.
Something to mull over. Thanks for listening.